Here in problem number 5, we're given a graph of a function f, and we're asked to identify which of the 5 options has a false statement. So there might be a more efficient way to do this. I'm just going to go through one at a time, see which one is true, which ones are false, see what happens. So in part A, or in option A, they tell us the limit as x approaches 2 of f of x exists. So let's see here. As x approaches 2 from the left, it looks like our function is approaching y equals 2. And as x approaches 2 from the right, looks like our y values are approaching 2. So yes, in part A, the limit exists, and the limit is 2. So now let's go to statement B. They tell us the limit as x approaches 3 of f of x exists. So let's check. As x approaches 3 from the left, the y values approach 5. As x approaches 3 from the right, the y values of f approach 5. Yep, this limit exists. The limit is 5. Now let's go to option C. They say the limit as x approaches 4 exists. Let's check. As x approaches 4 from the left, the y values of this function approach 2. And as x approaches 4 from the right, the y values approach 4. The left-handed limit does not match the right-handed limit. These values don't agree. So we're going to say that C is the false statement. Now, just for the sake of argument, let's keep checking the others and make sure that we didn't overlook something. So in part D, they talk about the limit as x approaches 5 of f of x. See, as x approaches 5 from the left, our y values approach 6. As x approaches 5 from the right, our y values approach 6. The left-handed limit agrees with the right-handed limit. So the limit of x, the limit of f of x as x approaches 5 exists and is 6. Now finally for part E, to determine if f is continuous at x equals 3, there's a good opportunity to review the 3 conditions that need to be met for a function to be continuous at a point, say when x equals 3. The first condition is that the limit as x approaches the point, in this case as x approaches the x value 3, would have to exist. So let's check. As x approaches 3 from the left, our y values approach 5. As x approaches 3 from the right, our y values approach 5. Yep, this statement is met, or this condition is met. The second condition is that f of c, or in this case f of 3, is defined. So let's just check. When x equals 3, there is a y value, and the y value equals 5. So condition 2 is met. So condition 3 simply says that the limit value has to equal the function value. Our limit value was 5. Our function value is 5. Statement 3 is true, or condition 3 is met, therefore statement E is true. The only false statement was in fact statement C. Hopefully this was helpful. Thank you for watching.